Hello, everyone. Thank you for having me here today. I'm going to talk about, like Nadia said in her nice introduction, about 3D printing with waste wood, the development of reusable printing material based on waste wood particles, and its digital manufacturing process for wall construction and architecture. My name is Heinze, as already mentioned, and I'm a research assistant with a training and design at the University in Kassel. And on the behalf of our team, I'm going to present our current results. But first, let's talk about the context of waste wood. On the photo, you see our facility partner, Kassel Recycling, where a crane sorts waste wood and places it on a conveyor belt so the shredder can shred it into fibers and it will be cleaned of any contaminants. Here we have an overview of all the waste wood categories, which in Germany are 4. The first one is natural and merely mechanical processed wood. The second includes painted and treated wood. And the third is defined by the use of halogen compounds in the coating. And finally, the fourth one is preservative treated wood. And even after the cleaning process, glass, plastic, and metal may still be present in the fibers, as you can already imagine from the colors of the fibers, especially in A3 and A4. In Germany, 9 million tons of waste wood is accumulated in every year, including industrial and sawmill waste, construction demolition wood, furniture that can no longer be used, packaging waste, and wood from outdoor areas. We have 2 strategies to recycle the wood, the material one and the thermal one, yet only 17% are currently recycled in Germany. Following changes to the Renewable Energy Sources Act, thermal recycling is no longer subsidized. However, thermal and material recycling remain equally important. This will change with the forthcoming law in favor of material recycling, which will further accelerate the problem of waste wood recycling. This gives us a good idea where we should think about using waste wood in a circular way. For a better understanding of our current project, I would like to give you a brief insight of our previous one, which focused mainly on the goal of using acoustic panels made from wood waste. The project was called Rethinking Wood, and basically we only used different sizes of wood particles with starch and calcium propionate, which prevents mold. And the fibers are mixed with water and the additives, just to activate the binder, so the used water is quite small amount. And finally, the mixture is put into a mold, any kind of mold basically, and pressed into form. Here you can see a sandwich element with 2 different sizes of wood particles. The video is a bit nicer with sound, though. The final product is fire retardant and biodegradable, so you can use the material again, and if desired, you can mix it with any kind of color and pigment. And for sound absorption properties, the sandwich elements can be improved using CNC milling. So basically to use the finer side to reflect sound and the cursor side to absorb sound. And here are two demonstrators of the pattern. And here you can see the finished demonstrator, which plays with the gradient of the particle sizes and surface heights instead of the sandwich elements. And the aim was to create a vision for use as lightweight, fire-resistant, and precisely manufactured insulation and acoustic element. And it could also be used in interior design, model, or furniture mating. And this project gave us an insight into the wood material itself and also established context with the industry partners that we still benefit from today. But now let's talk about the main topic, 3D printing with waste wood. The research can be divided into two areas, the technology itself and the material development. And right now our focus is more on the material side. And our research project aims to address two key issues, the material, as I mentioned, and the development of a wall construction. The objective is to develop a sustainable alternative through the integration of robotic digital fabrication, and the research aims to create a digital supported process using robotic arms and extrusion technology for the production of sustainable monolithic wall structures. To elevate the different factors which affects the material development, we have created this strategy that scales up in stages. So first, we used manual extrusion to develop a printable material. The second are benchmark tests in different scales, which are followed by diverse test methods, which I will address later. And in between the second and the fifth step, we are going to develop and design a wall structure, which we are going to finally print in 1:1 dimension with probably the help of our industry partner Rupp Gebäudedruck, who is specialized in 3D concrete printing. The material mix we want to develop should have the following properties: moisture resistance, fire retardant, mold resistant, good flowability during print, and should be fast drying. The wood fibers are from the company Jelowerke, and we are currently using wood flour with a size of 75 micromillimeters, and the formulations with different particular sizes and or fundamentally larger are yet to investigate. Because of the nature of wood, we need some kind of binder, and we used quite a variety. And these are the main four we are still investigating today: thiolose, starch, cellulose ether, and chitosan. And once everything is mixed together, we're going to print it. And in our current small setup in the lab, we are using an ABB 6-axis robot with a tool from WASP, a paste screw extruder. Sorry, I'm a bit nervous. Screw extruder, normally used for clay, and a 5-liter tank with custom-made nozzles. And for the next steps, we are currently developing a low-budget continuous feeding system and a larger extruder. The printed geometries are stored in a drying oven, and water loss is monitored by weighing the samples over time. In order to generate the necessary data, we have developed this categorization system to determine which material formulation can be tested using the usual methods for testing rheology, binding capacity, moisture determination, mechanical properties, fire behavior, millability, or finally, life cycle assessments. As of today, we have tested over 70 different formulations. The results and components tests show that the materials have favorable insulation properties. And at the moment, we are investigating the compressive load. You can see the pre-cut samples on the right. And after this test, we will be able to narrow down the formulation and print them on a small wall segment, as shown on the left side. And the problems we encountered so far are slow drying, cracking in between the layers, as you can see on the photo, huge shrinkage and poor flowability during printing, which increases print time. The results of the project indicates a favorable outlook for the planned application of a wall construction, whereby generated waste wood is processed through a zero waste approach into a wall structure with integrated functionalities, including installation management. The objective is to establish a closed life cycle, as illustrated in the accompanying image, from material over 3D printing, use case, recycling, and back to the material itself. The following example illustrates the type of wall structure that is being pursued, and due to the digital manufacturing process, it is possible to design custom cable and power outlets. And in order to improve the installation even further, you could add, for example, cellulose fibers. And that's it. So thank you for your attention.
Thank you, Lisa. Do we have any questions from the audience? Yes, over there.
Hi. Thanks for the presentation. Perhaps I missed it, but what binder materials are you using with the wood? What is the actual...
Right now, we're quite in the middle of developing the formulation, but the ones that are have the most potential are chitosan and starch or cellulose ether. So it's a bit of a mixture of them, but we didn't narrow down basically which direction we want to use.
Okay, and the follow-up is because I see you're using the wasp printer.
Yes.
So you treat it like a clay, essentially. The way that it's fed and the way that it comes out and the way that it hardens as well. Yeah.
Yes.
Okay.
Do we have any other questions from the audience? Yes.
Yeah, thank you for the presentation. Since you showed the previous project that comes with this beautiful and very controlled surface qualities, I was wondering whether you consider to post-treat the prints if you use them for interior walls to create a certain finish, as we maybe have seen it in Norman Huck's presentation, a kind of post-processing to get rid of the layering relief.
Right now, we haven't thought about post-processing the surface. I think during printing, you can custom the layering, so make it even more aesthetically pleasing. But it's a good idea for investigating that further. But right now, we just started it 1 year ago, so not there yet, but it's a good hint.
Thank you.